Okay, gee, how's it, guys? So, Luke, Warren, Kevin Heritage, my well-bearded friend over here. So we're going to talk about a bit of the basics of getting started functional programming in JavaScript. We're going to talk about a really cool library.
LiveScript.
Functional LiveScript. It's going to be epic. We're going to talk about a bit of Ramda. But to start out, let's talk about a bit of basics. So the first thing you need to think about when you're talking functional is functions as first-class citizens. And we've really got support for this in JavaScript. You set variables to functions, pass functions around as parameters.
You can return functions.
You can return functions. We're going to talk about that just now. Okay. And the next idea is this idea of purity and pure functions. And it's a function essentially that, given the input, always returns the same output, never mutates what's passed in, and it always returns a new state.
So, returning functions, we've got currying, which is a fundamental part of functional programming, where you return a function to create more specific functions. This can also be used to create scope in certain places where you can pass data to a function to later then use that function that has that scope somewhere else where you might not have that data. Ramda is a very handy curry function, which we'll be covering at a later stage. So here's a very simple currying example where we just created a prop function that pulls a key, well, it pulls a value that is at a key off of an object. Then we partially apply that to the prop function and just give it the age to create a more specific function. And then we've got a billy goat that's 10 years old, and we just give it the goat, and then we've got the age of the goat. But now we can use this age prop to pull the age off of any object, not just necessarily goats, which is a generic age prop function.
Cool. So the next sort of idea about going functional is this stylistic thing of point free, and we can attribute like my learning in this area to Ed, my good mate sitting over there. So this is all about avoiding the points. Okay, so the points would be your arguments. It's also called tacit programming, and basically it's less the name, less to get in the way, less unnecessary function wrapping.
Global variables forever.
Yes. Global variables wherever you can define them. Cool. So here's an example of a function that's not point free. You can see we're specifying our goat argument there, and then recalling our prop function we defined earlier with age and goat. Okay? We're not avoiding the point. And our point free example, there's no need to wrap it and provide an argument and name the argument. You just partially apply it and save it as a variable.
You get no points.
Thanks.
Okay, cool.
Basics
so
down.
That's the basics. That's all you really need to know.
So say hello to our little friend, Ramda.
Ramda. Okay, this is very dear to us. It's a little library. It hasn't got a huge footprint, but it's all geared towards functional programming. So it's all about creating functional pipelines, processing your data in terms of lists, and it's pure most of the time. Yes,
TypeScript.
There's sometimes you get involved with TypeScript and you might end up with some issues.
Not fun.
Much fun.
So you basically have all your basic iterators that you have in normal JavaScript. You've got your maps, you've got your for eaches, finds, filters, whatever you want. So for the purposes of this, we've got a data set of goats, which is Kevin Heritage, Luke Warren, LiveScript.
Unnamed Alex.
Unnamed Alex, yes.
Are you just calling it LiveScript for legal reasons?
Yes. 100% legal reasons. Not allowed to use that other word that shall not be named today anymore.
Yes. Larry will get hurt.
Yes.
I'm with you now.
So here we just have a function that pulls depends go to the name that comes in, and we say goat because goat is an array. There's a function on that called map, and we give it a function goat to string. That outputs the goat Kevin Heritage, goat Luke Warren, and a goat Alex. So now we go into turbo goat mode, where we require our map function there by destructuring the Ramda library. We just find that this works easier. You don't have r dot function littered through your code. You're more specific. As far as I know, it helps with the tree shaking, so you're only using the things that you actually you only have the things in your code that you actually need in the end. But back to the code now. The map function takes the same go-to-string function and makes it make go-to function. Simple as that. But it's only partially applied there. And you're also separating your data from your logic from your data. Then you can pass in your goats at a later stage, and you get your new goats, which is the same as the previous output. The nice thing about this is also that it reads from right to left. So your data goes in the one side and it pops out the other side where you want to use it. The for each also really simple. We're just logging out our goats, and that's pretty much it. Really simple.
Cool. So I really like this example. It's like how Ramda starts to get really useful. Okay, so we start off by importing a find function from Ramda, which is the same sort of find that you'll find in normal JavaScript, and also an equals function. Everything in Ramda, or just about everything in Ramda, is current. So we've got our equals function there, and we partially apply with Alex. So now we've got a more specific function that knows how to find Alex. We then pass our equals Alex function to our find function. Now we've got a more specific find function that knows how to find Alex. And finally, when we apply it, we get our Alex. So it's this composition, this building up of very specific reusable functions that starts to make Ramda really powerful, which is functional programming in general, very powerful. The next thing we sort of need to discuss is this idea of list processing. And I don't want to say list because I don't want to get any questions about it. So I'm just going to say list processing.
Just said it. You just said it.
And what we're trying to do is we've got some data being passed in, and we want to pass it through all of our functions until it pops out on the other side, or a state on the other side pops out that we want. Okay? So in this example, we've got goats that come in. We want to extract age and name from them. We want to sort them by age, and then we want to get the top one. And this brings up composability. Okay? So this is just using two or more functions together, building up these pipelines. It shouldn't be something that makes it confusing. It shouldn't obfuscate things. It should be highly readable. And Ramda, yeah, makes things really easy.
You guys can ask questions at any time. Interrupt.
Yeah.
Yes.
It can be an issue,
Yeah.
but it reads well.
Usually slow.
Cool. So in this example, we've just got normal live script mode, okay, and we've got nested functions here. Now the thing is that we're composing functions together, but it starts to get really messy, difficult to understand. You can see our point coming in here as goes. It's just horrible. Okay. So now this is where we introduce compose. Okay. So compose is a function that you use every day in Ramda. It's the best. All you do is you define all your functions that you want to run, okay, and they are in reverse order to how you're reading them right now. And then when you apply it, your data gets passed through from right to left. So if we look at our get on this go function that we define, we've got all our functions: extract age and name, sort by age, and get top row. That's the order. And when goes gets passed in, goes into your pipeline, gets extracted, sorted, gets top rows, and then our argument pops out the other side. We like the way this reads.
How does this work with asynchronous code when you need to connect to a database or something?
Then you use compose P. Compose P works just like compose, except with promises.
Okay.
Or normal functions, which is really cool.
Callbacks?
Yeah, that should be fine as well.
Well, then you start promissify and then you never worry about it.
Promissify.
If you haven't heard about promissify, there's a few libraries implemented. Node implements it. And basically, any error first callback code, you call promissify on it. It's promissify. Cool. So the next commonly used function is pipe. This is usually like a preference thing. You either prefer pipe or you like compose. We compose, guys. Alex down there, he loves pipes.
Grant also digs his
basically,
pipes.
the only difference is that it flows the other way around. So as you write your functions, that's the order that they're going to appear. So some people find this more logical. But yeah, it is what it is. It's just a choice you're going to have to make what you prefer.
The flow of data is also weird because now you're putting your data in this side and it goes to the top of the pipe or the left-hand side of the pipe, flows through it to the right, and then it pops out on the left-hand side again. So the flow of data is just weird to my brain. Then we get to the nitty-gritty of debugging Ramda, because that can be difficult. You've written all this lovely code that is 0.3 and you've got all these nice functions. Where do you put your breakpoints now? It's very difficult to find a place to inspect your function. So sometimes we need to break the 0.3-ness of our code in order to inspect something. So this is a simple example of breaking the 0.3 where we just take our normal, well, the top one is the new goat function, and there's no wrapping of it or anything. Then we just give it the goat and console.log out the goat, run the function, save the result of that function, output the result, and return the goat. Now, remember to return, because I've run into this a lot of times where I'm not returning, and you'll be searching for a while to figure out what the hell's actually going on. This sucks, it's not very maintainable. You're going to forget them there, and actually removing this is not so much fun. Then we go to our next example where we have a little wrapper function that takes in this function and then returns a new function for the data, and then we just do the same thing basically. This is better, but it's still difficult to remove one of these functions. So the way I prefer to do my debugging is by bringing in a compose pipeline basically. And there you just create this probe that takes the message and data, and then you put your probes in your compose pipeline, and it outputs wherever you want it to output, what you want it to output. It actually showed me this nifty little probe function. Thanks. This is better because now you can just, like, if you really need no console log, you can just comment out the one console log that you have, or you can just kill the lines which are probes. Really simple to remove from your code. Alright.
Cool. So let's get a bit fancy. So I think you can't really introduce a new library without saying, like, this is the whiz-bang feature. This is one of them, because we don't want to speak for 2 hours on Ramda. And this is called apply spec. So what apply spec allows you to do is define a specification for how to create an object. Okay? So in this instance, we're creating a goat spec. Knows how to create goats. Okay? I mean, you can see we've got our properties on the left there, as you would. Goat name, age, type, and meta. But on the right is always a function. Okay? And we can see we've got a meta property there, which is an object with another attribute function in it. Okay, what apply spec will do is when you actually give it the data, so that you'll see at the bottom there when we apply goat spec with our raw goat.js, that parameter, whatever parameters you pass to apply spec as the final arguments, will get given to each function and the value set to that property. So it'll recursively go down your entire object, create it, return it back to you. It's super powerful, and it's a nice repeatable way to create objects.
Always.
Sorry, Kevin's favorite thing is always. So this can really bite you.
Yeah.
So if you just want a string, so for example, if we wanted the type to always be goat, and if we just set type to a string, it would freak out and go into a fantasy land of wonder, and it literally will say fantasy land. So what you have to do is make sure that to the right you always have a function. Always have a function.
It's just trying to hold the string as a function.
Exactly. Exactly.
So you just call always with whatever you want it to always return, and whatever arguments it gets, it'll always return that same argument that you passed it the first time.
It's not actually trying to call the string. What it's doing is, if the right-hand side is an object, then it tries to find functions on that object. So it will recursively keep going ad infinitum, and you'll hit a stack overflow, because they'll never find the terminal function.
That's what fantasy land is.
Yeah.
Alright, now we get to one of my favorite functions, and that is the actual Ramda curry function. This function is pretty damn cool because you give it a normal function that has a list of arguments, and it'll curry that function for you. So here we just import the curry function, give it a function, here we create the find code within the loop, which is curry. Then we can create a more specific function of that to find a super goat, and then we can find the super goat by passing in the goats. But we can also at the same time take that same find goat with the loop and pass both arguments to it, and it'll execute once all arguments have been passed through to it. So there's no need to give it one parameter, open new brackets, give it another parameter, and so forth.
Cool. So just like in closing, it's a journey. Don't stop believing in functional programming. Again, I say, you just have to keep going with it. You have to sprinkle it in when you can. We started out with a little bit of functional and Ramda over here, and then it just started growing as the team starts to understand it a bit more, gets more comfortable with it.
I did a lot of function wrapping, unnecessary function wrapping. Ed can attest to this as well. And then eventually you find out you don't have to wrap your functions in a function because it's returning a function. You're just unnecessarily wrapping it. So you can start off that way and do it that way, and then eventually you'll see that you don't always have to wrap your functions in other functions. It's really a big mindset shift because now you're not thinking in terms of, I've got this big nested for loop array. You're breaking it up into small little functions that will eventually come together to solve the bigger problem. So you're breaking a problem down into smaller chunks to digest, and then they all come together to solve the bigger problem. So here's a few links that we've found helpful. We'll post the slides, post the link to the slides or post the slides after the talk tonight. Most important link of all is the bottom one, Ramda.js docs. The documentation of Ramda is pretty darn good. It's got a REPL that you can just go type in and hack away in the actual site, and it's just great.
Cool. Yeah, thanks guys. So, here's our Twitter handle.